Assalamualaikum and hello everyone. My name is Sofia Hani binti Mak Razali and we are from Group 4. We'll present about Numerical project. These are my group members. First one, Chai Hui Juan. Next, Nurul Nadira Nisa and me, Sofia Hani binti Mak Razali, and last one Hazwani Irina. And then these are the question. You must design using MATLAB and using Simulink GUI. We also will calculate manually and show to you also. Present introductions. This slide focus on circuit analysis using MATLAB. Second, Simulink is used to simulate the circuit using blocks. And third, GUI is used to create an interactive circuit tools. And next, circuit parameters R5 VA are varied. Second last, nodal voltage are calculated and analyzed. Last one, the aim is to understand and compare both methods. Okay, right now I will talk about method. First one, this project used MATLAB Simulink and a custom GUI to simulate and calculate nodal voltage in an electrical circuit. Second, the circuit is built in Simulink using standard blocks and put like resistor R5, voltage V, and current A are adjusted to observe changes. Third, a GUI is developed using guide allowing user to enter values and calculate voltage interactively with a button click. Fourth, manual nodal analysis is also done to verify the result from Simulink and GUI. Next, all three methods, Simulink, GUI, manual, are compared to ensure accuracy and consistency. Second last, input value are changed systematically to analyze circuit behavior under different conditions. Last one, the project includes a full report and video presentation to demonstrate the process and findings.
Hi, my name is Wan Hazwani Irina binti Rashidan. My matrix number CE241022. Okay, now I will present the manual calculation. This is a nodal analysis using a super node to solve for the node voltage in the circuit. First step, we need to super node. We create a super node between and because of the voltage source between them. The first equation is from the voltage source. Okay, for step 2, we use KCL at the super node. We apply Kirchhoff current law KCL to the super node, summing all current entering and leaving. The current through the resistor and the current source are written in the terms of the node voltage. This gives me the second equation. For step 3, we use KCL at node. We write the KCL at node again using Ohm's law to express current. And then got the third equation. For step 4, voltage dependent, the voltage source. The dependent voltage source is a given S. We rearrange it into another equation. For last step, we write in the metric form. Finally, we write all the equation in metric form so it can be solved using a calculator or any linear algebra method. For this part, this code is used to display an image inside a GUI in MATLAB. First, GUI data in bracket hash object handles update the GUI data so that any change to the handle are safe. Then exist in bracket handles exist one set the area where the image will be shown. In this case, is it's in the component name exist one. Finally, I'm show in bracket project GUI.gpg display the image file name project GUI.gpg inside that area. Okay, now I will explain the coding. So this MATLAB code is used to solve the circuit using a matrix method based on the nodal analysis. First, we get the user input values from the GUI. These are the voltage source, the current source, and the resistor. These values are entered in the interface and they convert from string to number using the str2 double function. Next, we define the matrix, which contains the coefficient from the nodal equation. Each row represents one of the equations we formed early from the circuit, including the supernode equation, KCL at node at the and the dependent voltage source relationship. Then we define the vector, which contains the constant from the right hand side of the equation. This comes from the source in the circuit. After that, we solve the matrix equation using m slash x, which gives us the node voltage V1, V2, V3, and V4. Finally, the results are displayed in the GUI by updating the text box with the calculate voltage value format to 4 decimal place. This allows the user to easily input value and see the calculate node voltage automatically. Okay, for the last part, for decoding, this part of the code handles the exit button in the GUI. When the user click the exit button, the function push button to underscore callback is called. Inside this function, we use the command close in bracket GCF, which is a closes the current GUI window. The parameter hash object, event data, and handlers are standard input in MATLAB GUI callbacks. They provide access to the button itself and any data stored in the interface. So overall, this function is used to exit or close the GUI when the user press the exit button. So that's all about the coding. Thank you.
My name is Chaiwijen, Numerical AE240046, and now I will present about the GUI layer which will compare the result with the Simulink. In this project, we got three set of number we'll compare. The first is voltage in 5, current in 10, and resistor in 15. We calculate we got 4, which is V1 is 19.5546, V2 is 13.5065, V3 is 14.5546, and V4 is 2.0962. And the second set number is voltage in 1, current in 2, and resistor in 3. We calculate we'll get the voltage all in negative, and V1 is negative 1.1096, V2 is negative 1.4711, V3 is negative 2.1096, and V4 is negative 1.2769. And the third number we calculate is voltage in 2, current in 4, and resistor in 6. We calculate we got voltage V1 in 2.70696, V2 is 1.1541, V3 is 0.7068, V4 is negative 0.8886. In this three set of number, all of the voltage V1, V2, V3, and V4 is in 4 decimal. Since we are based on the code we get and we have this GUI layer. I will present about the simulink, and this is the simulink layer of our group. Since we need to find V1, V2, V3, and V4, we got 4 voltage sensor and two again with two which related to the equation VA equals to V3 minus V2, and since we need to find V4, V4 is equal to 2VA, so again with 2 is need, and now we set the voltage in the first set number, which is voltage in 5, current in 10, and resistor in 15. We run, we will get V1 in 19.56, V2 13.51, F51, V3 14.56, and V4 2.104. And now we set the voltage to 1, current to 2, resistor in 3. And we run again. Now we will get V1 in negative 1.109, V2 negative 1.471, V3 negative 2.109, and V4 negative 1.276. And now we set the third set of number, which is voltage into current in 4, resistor in 6. We run again, and we will get V1 in 2.71, V2 in 1.154, V3 in 0.7103, and V4 in negative 0.8866. This is all of the result of our simulation.
My name is Nurul Nadiranisa binti Mat Nasir, number matric CE240094. Okay, now I will explain the discussion based on the result from both Simulink and the GUI application. Firstly, we can see that both tools provide consistent and reliable result when we change the input value of voltage, current, and resistor. Specifically, resistor 5, we observe predictable change in nodal voltage such as voltage 1, voltage 2, voltage 3, and voltage 4. This confirms that this simulation followed Ohm law and Kirchhoff circuit law. One interesting observation was the effect of resistor 5. When the resistor, the value increased, the voltage drop across resistor 5 also increased, which influenced the voltage at the next node. In other words, high resistor cause more voltage drop, just as we expect. Also, when we increase the voltage surge, the nodal voltage also increase, and when we adjust the current, in effect, the overall current distributed in the circuit. The GUI when very useful because it allowed us to quickly enter different value and see voltage output immediately. This is especially helpful for learning and testing process. On the other hand, Simulink provide more visual view of the circuit operation. It helps understand how the circuit behave in the real time. There's where some small difference between manual and simulate result, mostly like due the rounding error or summation made during manual calculation. But overall, all the method agree closely. In conclusion, this show the using MATLAB tools like Simulink and GUI is very effective and valid for analyze electronic circuit. Okay, to conclusion, this project clearly show the MATLAB, Simulink, and GUI are powerful tools to model, simulate, and analyze electronic circuit. By changing value like resistor, R5, voltage, and current, we were able to see how they affect the nodal voltage in the circuit. Both Simulink and the GUI gave us consistent and reliable result which match well with manual calculation. Simulink was especially helpful because it gives us a dynamic and visual understanding of how the circuit work in real time. On the other hand, the GUI used for quick and intuitive calculation, making it easy to test different values. Overall, this project helped us improve our practical skill in programming and gives us a better understanding of electronic circuit behaves using simulation and coding integration.